Let's talk about area under a curve. We have addressed this in the introduction to definite integrals. So if you did not watch the video on definite integrals, you might want to go back and take a look at that because we'll be building on that in the concept of area. The whole idea of finding the area under a curve stems from our discussion of inserting itsy bitsy little rectangles throughout the curve, and the width of each of those rectangles is dx, delta x, and the height of that is the function value. And so if we want to find the area under the curve between points A and B, we simply need to add up the area of all of the rectangles that are located here in our curve. And to add that up, and the integral symbol almost looks like the symbol for sigma, meaning sum, but we're going to add up all the rectangles from A to B, and we're going to add up the areas of those rectangles, and the area of the rectangle is f of x dx. So to find the area under a curve, from the curve down to the x-axis, we simply do the definite integral of the function height, which is f of x, dx. And so we'll be doing some examples very shortly, but that gives us the connection between adding up those rectangles and the integral. Now sometimes our curve is not above the x-axis. So if we wanted to find here the area between the x-axis and the curve from A to B, notice that our area is now underneath the x-axis. And what we need to recognize is that if we integrate from A to B f of x dx, just like we just did, then we would have to recognize that this value is going to be negative because it is below the x-axis. So when the value is above the x-axis, if this is our x-axis, when it is above, then it is a positive value for area, and when it is below, it is a negative value for area. So if you have actually started looking at how to use your calculator for this, you need to be aware that a negative area indicates not that the area amount is negative, but the direction in which the area is going is negative. It's below the x-axis. The other thing that we'll talk about is how do I find the area between two curves? So if I have these two curves here that are running in different ways, and we wanted to find the area from A to B between these two curves. Well, all we know so far is, and let's call this the solid function. Let's call this the dotted function, and so just D for dotted, S for solid, that if I do the integral from A to B of the solid function, that's going to give me this whole area right here. If I do the integral from A to B of my dotted function, that's going to give me the area below that curve. So remember, when we do one curve, it's from the curve to the x-axis. But if I want this piece here in the middle, then I simply need to take the first one, which is the top curve, and subtract the bottom, because then that will get rid of this big area right here, and I'll be left with the area in the middle. So we'll subtract. So what we typically, or what I like to write, is to find the area between two curves is you simply take the top curve minus the bottom curve, and you add up all of those areas by integrating. So top curve minus bottom curve is going to give you the area between two curves. So I believe on your notes page on the next one, this one is blue, so we'll call this B for blue, and this one is green, so we'll call this green, G for green. If I wanted to find the area between these two curves, if I just wanted this area, then I would do the top curve, which in this case is G, and the bottom curve, which in this case is the blue one, and I would do it just like we talked about, and we'll do an example. But what if I wanted to go all the way from A, let me see if I can draw that, to B. So I want to add this little piece in, so my picture looks like a fish. If I wanted to do that, I have in the first piece, the green is the top curve, but in the second piece, the blue is the top curve. So I'm going to have to break this into pieces. So to take care of the first piece here, I'm going to have to do we're going to need to know what that point is. I'll call that C right there. We're going to have to go from A to C, and we're going to have to do the green curve minus the blue curve. And again, the notes page has these in color for you. And then then we have to do the fishtail there, so area number 2. So this is area 1. And so for area 2, we'll go from C to B. And now the blue curve is on top, minus the green. And that will give us the area of that piece, and then we'll add the two areas. So you have to really have a good concept of what your graph looks like in order to do these. If I wanted to do the next one, you don't have to do the entire graph, but if I wanted to go just from A to B, okay, and again, make sure that when you're going from A to B, how do you know where B is? Well, sometimes it's given to you, but sometimes you'll have to find it by doing the intersection of the graph. Go from A to B, and again, we're simply going to do the top curve, which in this case was blue. I'm sorry, this should be a C right here because in your example I have B all the way out here. So this is a case where the first piece, the blue is on top, the green is on bottom, but then it switches, the green is on top and the blue is on bottom. And so you would have to find that point of intersection to know where to go to. So we would go from A to C, and in this case it switched. Blue minus green, and then the next one from C to B would be green minus blue. On the last example here, I wanted to point out, if I wanted to know this whole area right here, that is not the area between two curves. That's really just the area between curves and the x-axis. But again, the problem is that we've got two different curves here. In your note page, that's green and that's blue. So you would find that point of intersection, and then you would break this up. So we would go from A to C, where we would just use the green function, and then we would go from C to B using the blue function. And so now we're going to, in our next little clip, we will do specific examples, but this is just the concept of why the formulas look like they do, or how do we know whether to do top minus bottom. There's no magic answer. You have to look at the graph and determine what's going on. The biggest thing I would recommend or would worry about is remembering that when your graph goes below the x-axis, that you're going to get a negative value, and you need to make that a positive value to give the final area.